Welcome to ZoomInData. Hello everyone. Thank you for joining this focused session on concurrency and scaling in Azure Functions. We will cover how concurrency works, max executions per instance, host, JSON tuning, singleton locks, durable functions concurrency, scaling triggers, monitoring, cost optimization, and best practices to balance throughput, latency, and cost. If you are preparing for certification, an interview, or scaling functions at production level, this session will give you clear, ready-to-use knowledge. If you find it helpful, please like, share, and subscribe to ZoomInData for more Azure deep dives. Let us begin. How does concurrency work in Azure Functions? Concurrency in Azure Functions determines how many function invocations can run simultaneously on a single instance. The runtime manages a pool of worker processes and assigns incoming events to available workers. Concurrency is controlled per trigger type and plan. Consumption has lower defaults than premium or dedicated. Higher concurrency improves throughput but can increase memory usage and contention. Explain max concurrent executions per instance. Max concurrent executions is the upper limit of simultaneous function runs on one instance. In consumption plan, the default is 200 per instance for most triggers. In premium and dedicated plans, it is configurable and often higher, up to 1000 plus. Exceeding this limit queues new invocations. This can increase latency. What is website_max_dynamic_application_scale_out? Website_max_dynamic_application_scale_out is an app setting that limits the maximum number of instances the function app can scale out to. It is useful to cap costs or prevent overscaling during unexpected spikes. Default is unlimited in consumption and premium plans. Set it in application settings to a specific number, example, 10. How do you configure concurrency in host JSON? In host JSON, use the extensions section to control concurrency. Example: extensions, HTTP, max concurrent requests, 200, queues, max polling interval, 0 hours 0 minutes and 2 seconds, batch size, 16, adjust per trigger type, HTTP, queues, service bus, etc. Test changes with load to find the optimal balance between throughput and resource usage. Explain functions_worker_process_count. Functions_worker_process_count sets the number of worker processes per instance. Default is 1. Increasing it allows more parallel invocations per instance. Useful in premium, dedicated plans for CPU-bound workloads. Higher count increases memory usage. Monitor and tune carefully. What is the default concurrency model? Default concurrency is dynamic and trigger dependent. HTTP triggers up to 200 concurrent requests per instance in consumption. Queue, service bus triggers, batch size, default 16, controls concurrent message processing. The runtime scales instances automatically when concurrency limits are reached. How does scaling interact with concurrency? When concurrency limits are reached on all instances, the scale controller adds more instances. Scaling is based on event backlog, queues, or CPU, memory, HTTP. Concurrency settings affect how quickly new instances are needed. In premium plan, scale out is faster and more predictable than consumption. Explain singleton locks for concurrency control. Singleton locks ensure only one instance of a function runs at a time. Use singleton attribute on function or orchestrator for critical operations. It prevents duplicate processing, useful for timers or idempotent tasks. Singleton uses distributed lock in storage, adds slight overhead. How do you handle concurrent blob processing? Blob trigger concurrency is controlled by max concurrent calls in host JSON. Default is 24. Increase for high throughput blob processing. Use singleton if order matters or processing must be exclusive. Make blob processing idempotent to handle retries safely. What is the impact of concurrency on memory? Higher concurrency means more simultaneous invocations. Each uses memory. Memory-intensive functions, large payloads, in-memory processing, can cause out-of-memory errors. Monitor memory in Application Insights or Azure Monitor. Tune concurrency down if memory pressure is high. How do you tune concurrency for HTTP triggers? In host JSON, HTTP, max concurrent requests, 200, max outstanding requests, 400. Lower max concurrent requests for memory-heavy HTTP functions. Higher values improve throughput but increase memory and CPU load. Test with load tools to find the sweet spot. Explain concurrency in durable functions. Orchestrator functions run single-threaded. Concurrency is controlled by activity calls. Activity functions can run concurrently. Use fan-out for parallelism. Entity functions lock per entity ID. Concurrent calls to same entity are serialized. Tune activity concurrency with host JSON, max concurrent activity functions. How do you manage concurrency in isolated model? Isolated worker model .NET uses host JSON for concurrency settings. Configure max concurrent calls for non-HTTP triggers. Use ASP.NET Core middleware for HTTP concurrency control. Isolated model allows more control over worker process behavior. What is the role of Scale Controller? The Scale Controller is the Azure service that decides when to add or remove instances. It monitors event backlog, CPU, memory, and queue length. It reacts faster in premium plan than consumption. You cannot directly control it. Tune concurrency and host JSON to influence scaling. How do you monitor concurrency metrics? Use Application Insights. Performance Blade. Look at request concurrency. Monitor Azure Monitor metric, concurrent executions. Query log analytics. Requests. Summarize max, concurrent executions. By bin, timestamp, 5 meters. Set alerts on high concurrency or throttling events. Explain concurrency differences across plans. Consumption plan. Lower concurrency, 200 max per instance, slower scale out. Premium plan. Higher concurrency, pre-warmed instances, faster scale out. Dedicated app service plan. Full control. Configure instance size and count. Premium and dedicated offer better performance for high concurrency workloads. How do you handle high concurrency workloads? Use premium plan for pre-warmed instances and faster scale out. Tune host JSON concurrency settings to match workload. Use singleton locks only when necessary. They reduce concurrency. Offload heavy work to durable functions or external services. What is the max instances limit? Consumption plan. Up to 200 instances per function app. Region dependent. Premium plan. Up to 100 instances per plan. Configurable higher with support. Dedicated plan. Limited by app service plan instance count. Set website _max _dynamic _application _scale _out to cap instances and control costs. How do you prevent throttling with concurrency? Tune max concurrent calls to stay below downstream service limits. Implement client-side rate limiting in code or middleware. Use retry policies with exponential backoff for transient throttling. Shard workloads across multiple function apps if needed. Explain batch size impact on concurrency. Batch size controls how many items are processed in one invocation, queues, event hubs. Larger batches reduce per message overhead but increase memory usage. Smaller batches increase concurrency but add invocation overhead. Tune batch size with max batch size in host. JSON. Test for optimal throughput. How do you configure per trigger concurrency? In host. JSON. Use trigger-specific settings. Queues. Max polling interval. 0 hours 0 minutes and 2 seconds. Batch size. 16. HTTP. HTTP. Max concurrent requests, 200. Service bus. Service bus. Max concurrent calls, 16. Each trigger type has its own concurrency knob. What is the role of host-level concurrency? Host-level concurrency sets overall limits for the function app instance. Controls total simultaneous executions across all triggers. Use max concurrent requests in host. JSON for HTTP heavy apps. Helps prevent one trigger from starving others. How do you test concurrency behavior? Use Azure load testing or tools like Apache JMeter to simulate concurrent calls. Monitor concurrent executions in Application Insights or Azure Monitor. Test with different host. JSON settings to find bottlenecks. Check for memory spikes, throttling, or queuing during load. How do you optimize for cost with concurrency? Higher concurrency reduces execution time, lowers GBS cost in consumption plan. Use premium plan for predictable costs and no cold starts. Tune batch size to reduce per message invocations. Monitor and alert on overscaling. Set instance caps if needed. Best practices for concurrency management. Use premium plan for high concurrency or latency sensitive workloads. Tune host. JSON concurrency settings based on load testing. Make functions stateless and idempotent to handle concurrency safely. Monitor concurrent executions and throttling in Application Insights. Use singleton locks only for critical operations. They reduce throughput. Balance concurrency with memory and cost. Test iteratively. Set alerts on high concurrency or unexpected scale events. Thank you for watching this complete guide to concurrency and scaling in Azure Functions. From host, JSON tuning to premium plan scaling and best practices. If this session helped you with certifications, interviews, or scaling functions in production, please like, share, and subscribe to ZoomInData. More Azure deep dives are coming soon. Stay connected and keep learning. Thank you. See you in the next video.